Good afternoon to you all. Thank you for another lecture organized by the Agriculture and Plantation Engineering Sectional Committee of the Institution of Engineers, Sri Lanka. Today, we're going to be talking about a set of integrated solutions to fertilizer, base electricity, dairy products, and foreign exchange needs. Before we get started, let me introduce our prestige speaker, Engineer P.G. Joseph. Engineer P.G. Joseph graduated from the engineering faculty of University of Peradeniya in 1969. He obtained postgraduate diploma in industrial engineering from National Institute of Business Management, Colombo in 1979. He is a corporate member of IESL. He served as chairman of the Agricultural and Plantation Engineering Sectional Committee as well as Techno Exhibition Committee. He was the first general manager of the Energy Conservation Fund, presently known as the Sri Lanka Sustainable Energy Authority, and also the Director of Alternative Energy Division of the Ministry of Science and Technology. He is the pioneer of introducing energy plantation-based biomass power plants in Sri Lanka. He has received numerous national honors, including the National Science and Technology Award. So let me warmly welcome and invite Engineer P.G. Joseph to deliver the presentation.
Okay, good evening, everybody. First of all, let me thank the Agricultural Sectional Committee for giving this opportunity to participate in this Zoom meeting. Now, as introduced, specified in the introduction, what I am going to do in the next half an hour is to talk on some solutions or integrated solutions to four crises we are facing today. These crises are right. Let me go through the contents of my presentation. First, I will discuss about the four interconnected crises. Then I will discuss about background information on four subtopics. That is organic fertilizer, anaerobic digestion, dairy, and electricity. Then we will talk about a summary of my integrated solutions, but I am going to talk about. My solutions are actually in two stages, stage 1 and stage 2. First, I will talk about stage 1. It has actually three parts, existing cattle, new cattle, and non-dairy livestock. Then I will go through a series of pictures of Glyceria cultivation. Then we will discuss about the stage 2 solution, which is a little longer term solutions. Finally, we will discuss about recommendations and national benefits. At the outset, I must tell you that the solutions that I am recommending are not for immediate problems, so immediate crises. These are somewhat medium-term or long-term solutions. For the immediate crisis that we are encountering today, unfortunately, I have no solution. These are somewhat medium-term and long-term. So, having said that, let me go to the first set of slide. All right. So these are the four interconnected crises. There are four crises, and these are interconnected. First one is, as you all know, we have inadequate foreign exchange reserves in the country, and that is the one that is leading to most of our problems today. Then, as you all know, there is a big queue for dairy products. Then, organic fertilizer. Although the government started introducing organic fertilizer and stopped the import of chemical fertilizer, there is an acute shortage of organic fertilizers, right? then although and the other major crisis we are encountering is electricity. Particularly, we don't have base electricity. I will discuss about the importance of having base electricity later on. Now, let me go through the background information. First, let us discuss about the background information regarding organic fertilizer. Right? First and foremost, we must accept the fact that the present government has got the people's mandate to completely go for organic agriculture in about 10 years. Right? Now, most of the agricultural scientists have accepted this proposal, including the timing, which is namely about 5 to 10 years. But they have also warned the government not to rush into this and try to do this change in 1 or 2 years. That will be a problem. So, in principle, most of the agricultural scientists accept this changeover, but to do it in the proper phase of 5 to 10 years. Now, one important thing that we must realize when we are talking about organic fertilizer is that crops, whether they are whatever type of crop, they essentially can uptake only inorganic nutrients. The nutrients has to be in inorganic form, right? So when you bury the organic material like leaves or compost into the soil, the microbes in the soil has to convert all these organic matter into inorganic, soluble ionic form so that it can enter through the roots. So that is something that we have to understand. Although we use organic, ultimately it has to be converted into inorganic for the plant, the crops to make use of it. As a matter of fact, our annual requirement of nitrogen fertilizer is about 525,000 tons of urea equivalent. Remember, urea has a nitrogen content of about 46%. So 525% means 525,000 tons means into 0.46. Now, the second background information is now if you take a seasonal crop like rice or vegetables, and if you bury the organic material directly into the soil, you will find that you will not get the desired results, because by the time the microbes in the soil decomposes these organic matter into inorganic form, time has come to harvest the crop. So it is not useful, right? So what is it? Although this can be used for perennial crops like coconut, rubber, tea, and so on, but for short-term crops like rice or vegetable, we have to somehow or other find a way of converting these organic nutrients into inorganic form and then apply it to the crops that we are intending to apply. Then a word about aerobic composting or non-conventional composting method is that where you, when you convert organic material into compost or by aerobic composting, there are two disadvantages. One is a significant amount of nutrients get lost into the atmosphere, right? Whereas in anaerobic digestion, right, all the nutrients in the originally present in the material are retained in the effluent that's coming out, and they are also available in soluble inorganic form. So it is readily suitable for application to any crop. Even a short-term crop, you can, when you apply the effluent from a anaerobic digester, it is in soluble inorganic form. To accelerate this switch from chemical to organic agriculture, what that government did in Sri Lanka was they started importing organic fertilizers, but it resulted in serious drawbacks. One is the high risk of introducing dangerous pathogenic bacteria, and also it is high cost, and particularly in foreign currency. But fortunately, nature has provided a way of converting nitrogen in the atmosphere into organic matter through leguminous crops. Leguminous plants such as Glycidia convert atmospheric nitrogen into organic matter, mostly in leaves of such plants. Right? Trees such as Glycidia also have the ability to copies. Copies meaning you harvest a branch, you get new branches coming, right? And the leaves can be harvested approximately every 2 to 3 months. So once you plant a tree, you keep harvesting every 2 to 3 months for many, many years, right? One thing that we have to bear in mind is leguminous plants, although they have the ability to make use of atmospheric nitrogen, they do not have the ability to absorb other nutrients such as PK, calcium, magnesium, or what is known as micronutrients. Right. So, if we want to maintain sustainability, we should ensure that these leguminous crops are provided with adequate other nutrients such as PK and micronutrients. So this can be applied in the form of minerals. Minerals are technically they are permitted as organic fertilizers. So in the case of P, we can use muriate of potash, and in the case of potassium, we can use muriate of potash, and for phosphate, we can use rock phosphate. Now, but how does the anaerobic digestion take place? It is taking place by bacteria. The bacteria are required to convert organic matter into inorganic matter. You find that in cow dung, right? In the intestines of cows, you have it in a natural form. So when we start the anaerobic digestion, we have to inoculate the first batch fairly liberally with adequate cow dung, so that the anaerobic digestion process will start, right? As I mentioned earlier, this process of anaerobic digestion converts perishable organic material into inorganic soluble materials. Now, that is a picture of an anaerobic digester. It is simply a vessel where you introduce your organic matter and make sure that oxygen is, or air, that material is deprived of oxygen. That's why it's called anaerobic. So it has to be practically sealed, right? This is one form of digester where you have a tank, and on top of it, a floating gas holder. So, and matter is introduced from one end, and the sludge is taken out from the other, and the floating gas holder, the gas is taken out. Then we have another type, which is the Chinese type, where you build a big chamber, preferably underground, and there is no floating gas holder as such, but a big chamber built in that digester hold the gas, and when the gas pressure builds up, it slowly displaces the liquid into a bigger chamber, and the pressure is reasonably maintained. Now, there is another bigger type of industrial type of digesters. They are fairly large. This is the type of digester that we are talking about when it comes to power generation, where you have to make this tanks out of steel or whatever metallic material, and provided with various other additional accessories such as stirrers and so on. But fortunately, in Sri Lankan conditions, we don't have to provide any heating as such, because most of the time we will be using technology known as the mesophilic digestion, where we can manage with ambient temperature. Now, let me make a few statements regarding anaerobic digestion. Right. First thing is the entire amount of nutrients initially present in the effluent, that whatever material you put in, is retained in the effluent that is coming out in the form of slurry. Then, in terms of mass balance, about 90% of the mass that is introduced into the digester comes out as effluent, right? Plus, of course, the biogas, which biogas is the fuel that we are going to use up, which is mostly consists of methane and carbon dioxide, right? The nutrient that comes out of the digester are in soluble form and in inorganic form, suitable for immediate uptake by the crops. Right? Then typical resident time in a conventional anaerobic digester is about 14 days, right? But if we are using what is called the mesophilic temperature, right? But there is another higher technology that's available for thermophilic temperature, where the temperature of the digester is heated artificially to about 60 degrees centigrade. During this process, the resident time can be reduced significantly, less than 1 week, right? But normally it is much more sensitive, and it is somewhat you need fairly skilled operators to operate a thermophilic system. So by and large, most of the systems that we are proposing are mesophilic, that is, you operate at ambient temperature, right? Two things that we have to control are, one is the temperature, other one is the pH. If these two factors are maintained, the operation of an anaerobic digester or biogas digester is fairly straightforward. Now, some notes on dairy. Presently, about 40% of our milk requirement is produced locally, right? 60% is imported from overseas countries, notably from Australia and New Zealand and so on. When the non-availability or inadequate availability of foreign exchange, that is why we come across a shortage and big queues in the country. Now, government has got a mandate to reach self-sufficiency in milk in about 5 years' time. So that clearance is also there, right? Present, we have about 1.5 million cattle, but most of these cattle are open grazing. That is, they are allowed to graze in the open grassland, and in the evening they get back to the places and the milk is extracted. So this method of open grazing has two disadvantages. One is the efficiency, the productivity of the cattle is somewhat low because it gets sunburned and so on and so forth. The second one is we have lesser opportunity of collecting the manure from the cattle. So if we, instead of allowing the cattle to go open grazing, if we have what is known as stall feeding, that is to retain the cattle in one particular place and cultivate the feed and bring it and feed it to the cattle in stalls. This has the advantage that you get better productivity, in other words, more milk and more weight gain of the cattle, and you have easily collect the manure which can be used for as fertilizer and energy production, which I will discuss it later. Right now, of course, this stall feeding means that it is you have to cultivate the feed and you have to transport it, you have to pre-process it and feed it. So it incurs additional cost. However, this additional cost can be recovered from the benefits obtained by better productivity and by recovery of manure. As you all know, government has also specified that by 2030 we should reach our energy requirement 70% of our energy from renewable energy and 100% by 2050. Therefore, when we talk about electricity and energy, we should bear in mind that these two targets we have to achieve it. Therefore, we should focus on renewable energy, not on fossil-based energy, right? Then, when we choose energy options, right? One is the important thing that we have to bear in mind is foreign exchange. How much of foreign exchange that we are going to expend on different options available, right? Now, we have to bear in mind that the cost of generation of electricity has essentially two components, right? One is the cost associated with capital expenditure, that is your financing cost. Then you have the operational cost, fuel cost and maintenance cost. Now, if you consider renewable energy sources such as solar, wind, hydro, and so on, they have the advantage that the fuel cost or virtually even the maintenance cost is very little. However, they have fairly high capital cost. And the main feature of solar, wind, and hydro, as you may have realized by now, is that they are intermittent in nature and they don't provide what we call firm energy. This is why I mentioned about base electricity. What we need is firm power so that energy is available when you want it, particularly in the night and particularly in the dry season, right? So unfortunately, wind and small hydro do not provide energy during the dry season, and solar, as you know, is available only during daytime and it's not available in the night. So now, when we talk about electricity, just for your attention, we engineers speak about what is known as plant factor. That is the percentage of time the amount of the particular power plant delivers the energy. If we take solar, for example, solar power plant has a typical plant factor of about 17%. That is, out of 24 hours, it practically, on average, it operates only for 4 hours, right? For 20 hours, it doesn't produce energy, average, right? Then wind is much better. It's about 30 to 40%. Small hydro biogas. So these are essentially, they deliver firm energy. They can deliver, so long as you provide the fuel, it can operate more or less non-stop. They have an annual plant factor of about 80 to 90%, right? Now, when it comes to solar and wind and so on, because they are intermittent and because they are not available when you really want it, you need backup, right? So while the private sector invests money on solar and wind, the state sector, the CEB, has to spend money in providing backup facility. That is, they go for either coal or LNG or oil, right? So we are spending money twice. First by the private sector to put up solar and wind, and then the electricity board spends money in providing backup power, right? So the foreign exchange is spent twice. If you consider, for example, a solar power plant, right? Now, it will operate, as I mentioned, it gives output only for 17% of the time. So most of the time, it doesn't give output. Therefore, you have a backup plant, say, let's say an oil power plant. So that will operate most of the time. When the solar power plant is operating, then that oil power plant can stop spending for fossil fuel. And that is the amount of money that can be saved by operating the solar power plant. So if you do a calculation as to how long it takes to recover the capital that you spend on a solar plant by calculating the amount of money you have spent on avoiding that oil spent on the fossil fuel plant, it takes approximately, at today's cost, about 4 years, right? So now we have to take a hard look at when we spend money on solar, it will take 4 years for you to recover the foreign exchange that you have spent on solar system. So particularly when we are running short of foreign exchange, we had to think about this fairly carefully. Right. Now, let me also remind you at today's prices, the coal is being sold at $272 a ton. The unit of fuel cost of electricity from coal is about 30 rupees, right? And assuming oil, you can buy it at $100 per barrel, and assuming a conventional plant, the fuel cost of oil-based electricity is about 50 rupees. And the present approved tariff for waste to energy, municipal waste to energy project is about 36 rupees. Now, for agricultural waste, the existing approved tariff is only 23 rupees and 23 rupees per kilowatt hour. So it is, relatively speaking, it is much cheaper, right? But if you are considering intermittent plants like solar, and if you think of using batteries, say lithium-ion batteries, in an off-grid mode, and to supply you completely independent power, it will cost you approximately 100 rupees a kilowatt hour. This is my estimate. So now, summarily, what I am proposing is how we can solve these 4 crises are as follows. First, you cultivate feed crops, right? Preferably leguminous crops for livestock, right? And make sure that these crops are provided with P, K, and micronutrients. N can be obtained from the atmosphere. Then our dairy, presently we have about 1.5 million. This has to be increased to, we have to double it. It has to be increased to 3 million, right? Then promote stall feeding and not open grazing. Then next step is collect all the manure from the livestock. Now, organic fertilizer production and livestock are very much interconnected and very much interrelated. So livestock is an important part of organic fertilizer production, right? Then once you collect the manure from all the livestock, you anaerobically digest it and obtain 2 things. One is the slurry, it goes as the organic fertilizer, and the gas from the digester is used to generate electricity, because these power plants can operate practically right through the day and night. That is the summary of my proposal, but let me go through a little details. But this particular slide is somewhat difficult to read, so I will not spend time trying to read this. What I have done is, in the next few slides, I have divided this particular slide into 3 sections. Let me go to the first section, right? It is, I have 3 streams of obtaining feed material for digesters. First is existing cattle. As I told you, we have about 1.5 million cattle at present, and these are being fed from agricultural waste or from grassland, right? And because they are being open grazed, you cannot collect all the manure from this 1.5 million. I am estimating only about 1/3 of it can be collected, because in the evening the cattle comes to the stall and we can collect it. That's about 0.5 million of the cattle are collected to the digester. Then the second path is we have to increase this cattle population by additional 1.5 million, a total of 3 million. Now, these I propose that we let us have it in stall fed mode, so that we cultivate the feed, we bring it to the cattle and feed it and collect the entire amount of manure, right? So this will go in second plot. Third one is non-dairy livestock in the form of poultry, piggery, and so on and so forth. These are mostly fed with partly from MSW waste, hotel waste, and also from cultivated crops like maize and so on. And also we import certain quantity of feed for these non-dairy livestock like poultry. So the manure from these three sources are digested, taken to a digester. They are digested and produced in the stage 1, right? We hope to produce about 7 million tons of slurry, right? With about 500,000 animals, as I mentioned, because although we have 1.5 million animals, we could collect the manure only from about 0.5 million. In the second part I mentioned, we have to start dedicated cultivation for the new cattle that we are going to introduce, right? And that the new cattle population will be about 1.5 million. For this, we need about equivalent of 300,000 hectares. When I say 300,000 hectares, I am not talking about land exclusively for this. This feed material for cattle in the form of, for example, glycidia can be cultivated in existing agricultural land. For example, as intercropping coconut, right? As support for pepper cultivation, and so on and so forth. In fact, I will show you a series of photographs where how glycidia is cultivated in existing agricultural system without going for new land. So the 300,000 hectares I am talking about is not new land. It is actually presently used agricultural land for whatever purposes that they are using it now. So this will give you an additional 21 million tons of slurry. So this will go to the digester. Then the third one, as I told you, is the non-cattle livestock in the form of like goats, sheep, pigs, poultry, and so on. So this will give a small amount of estimated amount of 1 million tons only. Although these are large in number, but the manure produced by this category is very small. So these three will go to digester. As I mentioned, you see, existing cattle will produce 7 million tons. New cattle will produce 21 million tons, and other livestock will produce 1 million. So altogether about 29. Now this will give you two streams. One is biogas, other one is digested effluent, which will go as organic fertilizer. In the beginning, I told you we need about 550,000 tons of urea equivalent. That is equivalent to 260,000 tons of nitrogen. So this can be obtained from these three sources that I mentioned. So in other words, if we reach self-sufficiency in milk, we automatically reach self-sufficiency in organic fertilizer. These numbers match each other. So once you reach self-sufficiency in milk, you automatically reach self-sufficiency in organic fertilizer. The side benefit, the auxiliary benefit is electricity. Of course, we will not be able to meet the self-sufficiency in electricity because electricity produced from this process is relatively small. It's only, I estimated only about 250 megawatts. That's about 2,000 gigawatt hour per year. This is about approximately 12.5% of the electricity that we are producing now from all the sources put together. We are producing about 16,000 gigawatt hour per year. So this is 1/12 of that. Now, talking about the next stage, the second stage, we, in addition to material which we can use as feed material for cattle or livestock, we also have other perishable material which cannot be used as feed for livestock, right? All the leaves that we get are not cannot be used as feed for cattle. Now, there are a number of methods by which these are presently used to dispose it. One is household composting. Well, that can go on as it is. Second one is at industrial level, it is being composted. But I personally don't recommend this because, as I mentioned in the beginning of my presentation, this composting is not an efficient method of converting your organic material into fertilizer. Right. Secondly, we are also using some of the material, but we are easily biodegradable material by combusting it to produce electricity. Right. So these items like plastics or paper or hardboard can be used, but perishable materials like organic material are not suitable for combustion. So this is not recommended. Then some of our material, perishable materials, are also taken for landfill. So this is also not recommended. Second thing is, by and large, most of the degradable material that we get in the village area, rural areas, are simply heaped and burned in the open. Now this must stop, right? This is a very wasteful method of disposing our method. Now what I am proposing is all these material which cannot be used as feed material for livestock, let us use them to in a digester to digest and produce biogas and digestate organic fertilizer. By this, my estimate is that we will have about 60 million tons of per year of such waste available in the country. And if we digest this, we should be able to generate about 600 megawatt of electricity and about 54,000 tons of nitrogen equivalent. Now, as far as electricity is concerned, it is even 600 megawatt is relatively speaking is a small quantity compared to our requirement. But for fertilizer, as I mentioned earlier, if we reach self-sufficiency in milk, then we would have produced all the organic fertilizer what we require. So by converting this waste material through digester, whatever slurry that we are producing in this digestate become a surplus organic fertilizer. This probably we can start exporting it. Now, some of the features of my proposal we have to keep in mind are as follows. One, which, as I mentioned earlier, the new cattle that we are going to introduce, as I mentioned, about 1.5 million new cattle should be stall fed and not be allowed to open graze. Right? Then the land area required to cultivate the feed required for the cattle, the 1.5 million new cattle, is estimated to be 300,000 hectares on the basis of 0.2 hectare per cattle. But as I mentioned, these are not the new land, but these are simply land which are presently used for various agricultural purposes, right? Then I will make some recommendation how this whole process can be marketed. But the urea with 46% nitrogen we are purchasing it at before the crisis, we were purchasing it at $879 per ton, right? Now, glyceria leaf, once it is dried, it has a nitrogen content of 4%. Therefore, I calculated it, a kilogram of dry powder should be valued at 23 rupees per kilogram. So if the fertilizer corporation in the country can offer 23 rupees per kilogram of dried glyceria leaf, a lot of farmers in the rural areas should be encouraged to do this. Now let's go quickly through some of the pictures that of glyceria cultivation. Let's not waste too much of time. I will glance through it quickly. Right. This is agroforestry where various trees and glyceria are grown together. This is avenue planting. That is, you have rows of glyceria with coconut in avenue form. Then this is a cattle buffaloes fed with rice straw and glyceria leaves. And this is glyceria tree planted with big cuttings. This is agroforestry for dragon fruit. This is live fence, right? And photo production and for soil protection. This is a person by the name Lionel Viracon introduced a new method of nursery where he takes sticks and keep it for about a month. And when it starts sprouting, and once it's sprouted, he takes out and start planting it. Then pepper under coconut, right, agroforestry. This is pepper trees. Glycidia used as a support for pepper. Roadside plantations, right? And this is called SALT, Sloping Agricultural Land Technology, where glycidia is grown to prevent soil erosion. Then this is glycidia seedlings before planting. This is glycidia being used as a shade and also as green manure for tea, right? This is glycidia used as support for vanilla. And now this is a picture of a 10 megawatt livestock waste producing electricity through a biogas process. Now, this project proposal has been submitted to the CEB about 3 years ago, right? All the approvals have been obtained, but CEB is not giving the clearance to proceed for some legal technical reason. But if approval is granted, this project can be started. Right? Now, let me come to the recommendations. First, in 2005, the government declared glycidia as a fourth plantation crop, but nothing much has happened since then. So the first thing that I am recommending is that the present government ratify this decision and rename it as the glycidia to be declared as the fourth plantation crop. Then we must constitute a new task force to make sure that all state land, right, be utilized to produce feed for livestock. So if we are going to achieve self-sufficiency in milk, we have to produce feedstock. And to do that, the state sector land which are not utilized fully should be utilized to produce livestock. Then also, whatever the department, the NLDB should preferably declare leaf powder as a commodity and make arrangement to give a guaranteed price. As I mentioned, it's about 23 rupees, so that the villagers can produce it and market this. If we are going to achieve self-sufficiency in milk in 5 years, I think the NLDB should take the lead, and the government should NLDB should be mandated to take necessary steps to achieve this in 5 years, right? And presently, a number of renewable energy projects are on hold because the Ministry of Power and Energy and the Sloan Electricity Board have not finalized the standardized power purchase tariff. So now that this should be done forthwith without any further delay, right? Secondly, if we want to make renewable energy-based projects, electricity generating projects viable, this tariff committee should meet frequently and must revise this tariff to make sure that this renewable energy sector is supported, right? Then recently, in January, the Ministry of Power and Energy introduced a gazette number 2261 of 18, recommending a number of methods to encourage the private sector to start renewable energy projects. But this should be implemented without any further delay, right? Now 3 months have gone, nothing much has happened, right? And the tariff committee is still living on it, right? Right. Now, next one, both the Ministry of Power and Ministry of Agriculture should jointly promote the establishment of anaerobic digestion in close proximity to the livestock farms and produce biogas-based electricity generation. And a suitable tariff should be introduced, and the liquid fertilizers coming from these digesters should be marketed by the fertilizer secretariat. And the fertilizer secretariat also should introduce the liquid fertilizer as a commodity and they should introduce a set of network to make sure that this liquid fertilizer is conform to the Sri Lanka standard. Also, the standard has been established and facilitate that these products' quality is maintained. These are the national benefits, right? First, we will reach self-sufficiency in milk. Then we will also reach self-sufficiency in fertilizer in the form of organic fertilizer. In stage 1 of the proposal I mentioned, we will meet 12.2% of electricity from reliable sources, right? And we will save foreign exchange presently spent on importing milk, importing fertilizer, and importing fuel for electricity. Then rural economy will expand in the form of cultivation of glyceria and fertilizer, and a lot of scrub land which are presently idling will be converted into glyceria plantation, thus protecting it. And the villages will benefit from sale of cattle feed, milk, livestock, electricity, and repeat fertilizer. And lastly, also because all this technology are low carbon technology, this will have a reduction of GHG emissions. Okay, thank you very much for your listening. Now we will accept questions if you have any. Thank you.
Am I audible? Thank you very much, sir, for your wonderful, timely and very useful presentation. Now it is open for question and answer. So if I think there's one question in the chat box. Can you see, sir, this question?
The West climate emergency experts are worried about methane gas produced by cattle before fermenting the manure. How will this initiative respond to such concerns? This is an issue. If this is so, then we have to think of a method of producing milk from non-ruminants, right? That is a long way off, right? So if the scientists can find a practical method of producing milk from non-ruminants, then this problem can be solved. But until such time, we have to depend on ruminants to produce milk, and all ruminants do produce methane before we make use of the manure. Unfortunately, this problem cannot be solved at our level. Second question. Sorry, it is a question, is it? It's crucial to. What about this part? This one is already answered, right? It is crucial to understand how cow manure is currently used. Is anyone aware of how many residential biogas digesters are now in use? Yes, I think there is a project undertaken by the Sri Lanka Sustainable Energy Authority. I tried to get the statistics from them, but they told me is they are not sure whether there are, in fact, many plants are in operation, but they are not sure of exactly how many plants are actually in operation. They don't know. I think we were in touch with Sustainable Energy Authority. They should be able to answer this question because they have a special project undergoing this. There are numerous plants, but not much is happening. Then what happens to the cattle after the milk producing livestock? Well, this is a very important question, right? Unfortunately, it is a social and shall we say religious issue, what is happening now is these cattle are just being maintained as cattle, right? But of course, if the government decides to solve this problem, they could export the cattle for meat production. But that is what's happening in many other parts of the country. For example, India, what they do is they export the cattle to some other country, so it's being used as meat. But anyway, this is a social problem. But what is happening now is this after milking period, the cattle are let loose and they are being maintained as a non-productive manner. Then, sorry.
I think next question, Engineer Parakrama Singh, he says he raised his hand. I think he can ask the question.
Yeah, thank you very much. Thank you very much. Joe, as usual, a fantastic presentation. And but I want to add one, because you left out dendro energy. Because when you are producing your Grisidia leaves or your cattle feed and all other things, you do get the sticks also, which will give a much renewable energy addition also, which is not in any way upsetting the program that you are having, but it will be added one. And the ADB says we have potential about 2,500 megawatts of firm energy. That also should be counted in somewhere in support of what you are presented. It's fantastic. But also, I want to add two more things to the questions that were raised. One is about this. Now, as usual, when the developing countries are trying to do something, the West comes and says something to block it. Or this talk about methane from cattle, it has been there forever, right? So we are not adding to that one. Compared to what the methane emission, natural gas, both production wells in the piping system and all that is much more. Why don't we look at that one first and get out of the natural gas usage first? That will impact on the climate change. Those are all what we are called red herrings to prevent us from doing something of value. One other small comment, as far as I know, my friend Dr. Gamini always used to say, people think what happens to the cattle after they are finished their sort of production cycle. He used to cite an example of, in Gampala, where he met some farmers. So he took them around and showed various places where the old cattle are buried. They are allowed to roam around till their natural life is end, and they are buried. And of course, they would add to the fertility of the land also. In Sri Lanka, I don't think this was ever a serious problem. You see, people let them, yeah. So that should not be considered as a deterrent to what is being proposed by Joe. So those are the two comments I want to make. Thank you, Joe, very much for bringing this up. This is all we have been talking about for long. Nobody pays any attention. So at least now, for instance, what you mentioned about your project of 10 megawatts, it had taken 3 years. But as you know, dendro projects have been blocked for 7 years without any being approved by the CEB. Talking about legal issues and all kinds of nonsense. You see, at least now they are talking about amending the act. How long it will take? In the present context, when everything has gone into real turmoil, that will again go under the carpet, and we'll again be forgetting about that one while talking about we have to find the foreign exchange to buy your diesel and coal. This is the tragedy of this country. So, but this has to change by people who are in this audience. The change must come from this. Expect it to be given to us. We'll have to make that change. I propose each of you go and plant a Grisidia tree by yourself at least. You see, that's the way to go ahead. It's time that we took this decision into our hands and do what we can. There are many other, right now, even if you don't go for dendro power, having Grisidia is a means of kicking the LPG habit. You plant your own fuel. You see, there are a number of people who are now producing very good stoves, which can be used with the fuel wood. So you don't have to worry about going and sitting in to pay 4,000 something for a cylinder of gas, which you don't know where the next one will come in from and at what price. So those are the changes that should happen. All that is, as we say, is crucial and also central on this, our ability to look at what we have. Fortunately, greasy days, a wonder tree, although it's not ours, came to us about 300 years ago. It's a wonder tree. So that is what we should use. And Joe very clearly explained the many aspects of it. Thank you, Joe. Thank you very much.
Okay, thank you, Farah, for those encouraging notes. I agree with you that we should also consider the use of the sticks. But my contention is food. Food is priority number one. For food to be produced, we need fertilizer. So if you are going to concentrate.
No, you are missing the point. You are missing the point. You are getting your fertilizer. You are getting
let me complete
cattle feed also, but you also get the wood. You are not.
Let me complete it. Let me complete it. Let me complete what I say. Right. So now we have to give priority. Right. If you wait till the trees grow big enough for the wood to be used, then you will have to harvest the branches approximately once a year. So, but I am
8 months.
No, okay, once in 8 months, let's say. But I am proposing, if you are going to feed it to cattle, you harvest it every 2 months, 2 to 3 months.
So plant twice the amount.
What I am saying is now we have to concentrate. We have see here is there's a priority. The priority is fertilizer. So if you delay the fertilizer, then we are in for trouble, serious trouble. So let's do. I am nothing against what you said, but since we have to prioritize our need, and so that's why I say you harvest your branches every 2 to 3 months. When you harvest your branches every 2 to 3 months, you will not get any woody material. So that's why I have not considered. But well, I have nothing against your option. But maybe we can reach a compromise. But my priority is, if we don't reach organic fertilizer quickly, my position is we will run into serious problem of a shortage of fertilizer. And fertilizer is number one problem in the country. So we have to produce it. Anyway, that's my view, but I have nothing against using the wood. Well, if we can, both, let's do that. Then now let's go on to the next question. That's okay.
Joseph, there's the one gentleman, this engineer Jayanta Sirikumar, he raised his hand. Let allow him to talk. Can I?
Please, yes. Okay. There's a question. Yeah.
Good afternoon. Thank you very much for giving me opportunity. It's a very nice and timely, important presentation. I'm Jayanta Sirikumar from Sri Lanka Standard Institution. 3 months back, I returned from Bangladesh. I did the study on biogas in Bangladesh household. So I was thinking that how many biogas plants now currently housed in Sri Lanka. I heard that it was around 14,000 biogas plant, domestic biogas plant. As Mr. Joseph correctly mentioned, out of 1.5 million cattle, most of the cattle are located in the suburban areas. Then the material, the cow dung, where it is produced, can be used, and most of the gas problems can be solved if we can have a mechanism to drive this domestic biogas plant, so that LPG, whatever we import, at least some amount of imports can be substituted by the methane or biogas. So it is worth to do, I think, a study on existing biogas plant and see what are the barriers, what are the drawbacks, socio-economic and other environmental aspect of it, so that we see the changes, what we can do. This is just for my thoughts. Thank you very much for Mr. Joseph for a very useful presentation. Thank you.
I totally agree with you. Yes. There is a question about in parallel we should invest in solar. Yes, solar I am totally supportive of it, But all I am saying is, in the present crisis of foreign exchange, right, we have to be a little cautious about solar, because when you spend money on solar, the foreign exchange that you spend on it will result in reduction in use of oil in producing electricity. As I did a small calculation, it takes 4 years to recover that capital. So for you to spend money today and wait for 4 years to recover it is it's not a very prudent thing, considering the plight of the foreign exchange situation today. So in theory, yes, solar should be encouraged, but because of the current crisis, we have to be a little cautious about spending too much of money on solar. That is my personal view. The next question is, thanks a lot for AD is a very old technology, but in our country it is still not popular. Reason, yes, but what I am proposing is kind of an industrial levels type of biogas plant, fairly large one, right? Where you produce a high value product like electricity and commercial fertilizer. So the small rural scale technology, they are viable only if you don't give any value for your labor and so on. If if a housewife spend time in feeding the digester, and if that the time spent on that is not accounted for, then it's viable. But in today's situation, people they are very busy. Every woman, every man is trying to do something to earn. So I am proposing, commercial operation thing, right? Large ones and on an industrial scale, so that they produce commercial products like commercial fertilizer and electricity. Is there any other questions? No. Okay, it looks like I have answered all the questions in the chat box.
Yeah. Engineer Parakrama is again in the.
Can I make another small comment, please? You see, just a comment. Recently, I was told by people who are already in this agriculture sector, you say there was a large number of domestic or farm level biogas units. You see, where some of them are sort of getting away from it. In the early days, they had rid of the effluent because they did not really recognize the value of it. But of late, they have recognized that one, and that has become excellent fertilizer, and there are people chasing after it. I was told they get about 80 rupees a liter for that one. So they are reviving that one, which is a very good sign. And hopefully that would add to the number there. And unfortunately, there are nobody looking at this in a holistic manner to find out why they are not promoted and why more people are not brought in. This is the whole problem with the country. You see, one hand doesn't know what the other hand is doing. The value of this integrated approach that Joe mentioned is not there at all, which would have done a lot of good. But anyway, also one other comment, Joe. My calculation shows the foreign exchange spent on solar can be recovered in 2 years. That was before prices started going up at the present rate. So I think it might be even less. So that is one. And recently the chairman. Joe, we will argue about it privately without going into it. I'm just commenting, right? Other one is the chairman SCA in a percent that the cost of adding batteries at present is only 8 rupees per kilowatt hour, and it should come down to about 3 rupees by 2025. I don't know how accurate that is. That was his assessment. You are saying that it's going to be 100 rupees a total. It needs to be checked. Well, let's check on that. Thank you. Thank you for the time given.
Okay. I listened to various international.
Engineer Joseph, sorry, actually I joined later. I don't know whether you... Yeah. Can you hear me? Sorry.
If you want to I think there's now answer to Paras question about the grid parity. This, according to my calculation, I have listened to various eminent people speaking about grid parity with solar. If solar were to be provided with battery storage and be completely independent of the grid, right? Then it will the cost will be about 35 US cents. That's why it will come to about 100 rupees. What they say is in countries such as Germany or Denmark, where the present electricity prices are in fact in that region, about 35 US cents per kilowatt hour. It is in those countries that solar with battery are competitive with grid. When they say competitive, it is completely independent of the grid. If you are going to use the grid as the means of supplying, then it's a different story, economics. But if you are going to completely go off the grid and stand all by yourself with solar and then battery, it is about that, because I try to get a quotation from local people for a 2 kilowatt system. They are asking for 3 million rupees, right? That is using lead acid battery, right? So it is the one person was genuinely interested in operating a 2 kilowatt system for his computers, but he gave it up because it's so prohibitively expensive. Anyway, we'll see how things go.
Engineer Joseph, this is Amy here. Hello. Yeah, can you hear me?
Yes, go ahead.
Sorry, actually, I joined later because of this power issue, and I don't know whether you have explained this. I have a small question. So, is there any other part of the world? Is there this kind of application, this kind of system application in the other part of the world?
Yes, this use of an industrial level livestock based power generation is common. It's common in many parts of the world, right? In fact, the International Energy Agency has introduced a new section on. They are talking about cultivating crop exclusively for anaerobic digestion. But I am not talking about that. What I am talking about is we need to start with. We need two important things. One is milk. Second thing is organic fertilizer. These two are absolutely essential. So let us achieve that. While achieving it, then we get the electricity as a byproduct, right? About 250 megawatts, right? While achieving self-sufficiency in milk. So if we decide, okay, if our children do not need milk, then it's a different story. But then we have to provide that milk. No? Either we grow it ourselves or we import it. But importing milk is not a solution. So that's how we have to look at it. But industrial scale biogas plants are quite common all over the world.
Thank you very much. I think the forum is still open for the question. So if anyone of you have a question, please.
Yes, I want to just thank Joe for the integrated approach that you have brought in. I'm KKY Abdul Pereira. Thank you, Joe.
Thank you very much for your participation. We really appreciate. Please go ahead. Yeah, please go ahead, sir. Yeah.
Thank you, sir. Thank you, Professor Pereira. Thank you, Professor Pereira. Yeah, thank you, sir.
With quantities, this is the first time I quantified approach on integrated solution. This is the first time that I listened to it. So thanks, Joe. Thank you.
Thank you, sir. Thank you very much for your comments. It looks like all the questions have been answered.
The engineer Joseph, then I think, I don't know whether we have very fruitful discussion today, and you made a wonderful presentation, and following that we have a very wonderful, very fruitful discussion, very interactive session. I don't know whether we can make a kind of proposal to government. So maybe Engineer Parakrama was making some argument. So that is a very good sign. So if we all can get together and make a presentation, sorry, proposal to government, that would be nice. So we'll see whether we can do it. And
we should do that. Yeah, I'll be happy to help.
Yeah, please. Thank you so much. Even others can be others can.
Can I say one word on that? Government had appointed government had appointed a subcommittee of technical subcommittee from ministers and MPs for solutions to this problem, energy. And there are several MPs who are interested, and if Joe can make a presentation to them, I can arrange. The ISA can do it. It is
Yeah, sir,
better.
thank you very much, sir. So we will contact, we will liaise with you regarding this so that.
Thank you very much, sir.
Yeah.
Yeah, it's very good. It's a very timely, important idea. Thank you, Mr. Hemichan. Yeah.
Yeah. With that, I think before closing, let me thank our lecturer today, Engineer PG Joseph, who is a very senior engineer, and he opened our eyes and gave a lot of thoughts, and we understand very senior people join as a audience in the audience today. I think we can continue this discussion and make a proposal. And finally, I would like to thank you all for joining with us today on behalf of Agriculture and Plantation Engineering Sectional Committee. Thank you very much. And
Okay, thank you, everybody. Thank you, everybody.
Thank you. Thank you very much.